In this video, we're going to be taking a look at essentially quartiles and box and whisker plots. Which are also sometimes just called box plots. So quartiles, when you see the word quartiles, that prefix quart usually means 4, right? Quart means 4. So what we're in fact talking about doing when we take a set of data and essentially divide it into quartiles is we are dividing the data between your min and your max into 4 equal pieces. Okay, quartiles are these 4 equal segments of your set of data. And certainly you could start at the left-hand side and make a cut here and a cut here and a cut here, but we want to ensure that the pieces are equal. So just like trying to cut a piece of string into 4 equal pieces or a piece of cake into 4 equal pieces, the easiest way to do that is to make a cut right in the middle and then take each half of the data set and divide them in half again. And then we ensure that we have these 4 evenly distributed subsets of data. Now this cut that's right in the middle, we've already talked about that before. That's the median, right? The point that is literally the middle point of the set of data when the data is put in order, that's the median. This value right here, the middle point of the lower half of your data set, is called Q1. And this point right here that is the midpoint of the upper half of the data set, that is called Q3. And because this is Q1 and Q3, sometimes the median will also be called Q2. Okay, but each of these subsets of the overall set of data, the essentially the segment between the minimum and Q1, between Q1 and the median in Q3, and Q3 and the max, each of these has 25% of the overall set of data in those subdivisions. So if you had 100 pieces of data total, 25 pieces each would end up being in these 4 subdivisions. Okay. Now, if this set of values looks familiar to you, minimum, Q1, median, Q3, and max, that's because it's called the 5-number summary. And on the calculator, it's the very last set of stuff that we've been seeing when we run one variable stats. Right? It's the very last set of stuff. We get the minimum value, the Q1, the median, Q3, and the maximum. Okay, so that 5-number summary, when you run one variable stats on the calculator, this is the last chunk of stuff that you get. And one of the main focuses of this section is on creating a box and whisker plot. And all that a box and whisker plot is a box and whisker plot is a graphical display of the 5-number summary. Just like a histogram was a graphical display of the data contained in a frequency table. The box and whisker plot is just a graphical display of the information that's given in a 5-number summary. So I want to show you how to do this, and I also want to show you what happens when you have a set of data where there is an outlier present. Okay, so I want to show you how to do it by hand. Also want to show you how to do it on the calculator. So let's say our set of data, let's say that we've got maybe, I don't know, 25 pieces of data or something. So let's say we've got 8, 9, 10, 10, 12, let's see, 1, 2, 3, 4, 5, 6, 13, 13, 14, 15, is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, okay. And then maybe we've got 18, 19, 19, 19, 23, 25, 33, 38, 42, 44, 45, 45, 45, 46, 47, 48, 48, 48, 50, and then maybe, I don't know, 108. Let's say that's what we have. That might not actually end up being an outlier. We'll see what happens with this set of data. But here's our set of 30 pieces of data. Okay, so there's 30 pieces here. Now, if we're going to make a box and whisker plot, whether doing this by hand or on the calculator, we'll need to start by putting the data into a list in the calculator using the procedure that we've already learned. So we will go into Stat and select option 1 for Edit. If you have data that are already in there, you'll want to clear them out. Get rid of those sets of data. And then we're just going to be putting in these values. So we had 8, 8, 9, 10, 10, 12, 13, 13, let's see, 13, 13, 14, 15, 18, 19, 19, 19, 23, 25, 33, 38, 42, 44, 45, 45, 45, 46, 47, 48, 48, 48, 50, and 108. Okay, so we've got all of our pieces of data in there, all 30 pieces. Now, to get the 5-number summary so that we can actually do the box and whisker plot, again, we would go to Stat, over to Calc, so we press the right arrow key to go over one to Calc. We want to select one variable stat, so that's option 1. For those of you with the new operating system, here you'll have a thing that says list, I think, and frequency list. So if you have your data in list 1, list should just say L1 and frequency list should be blank. For those of us with the old operating system, 1 var stats, we need to press second 1 to get our L1 to pop up. Or if your data are in some other list, you would tell the calculator that, and then press enter. And it gives us a ton of stuff, but what we really need is way down at the bottom here. Okay, we need that last 5-number summary: minimum, Q1, median, Q3, and maximum. Okay, so minimum for this set of data was 8, which clearly we can see they're already written in order. We know what the min and the max are without actually having to do the computation in the calculator. Q1 is 13. Median is 24, Q3 is 45, max is 108. Okay, so there's our 5-number summary. Now, before we create a box and whisker plot of this 5-number summary, there's one additional thing that we need to do. We need to look for outliers in our set of data because they are displayed differently on a box and whisker plot. They're displayed separately from the rest of the data. And the way that you look for outliers, looking for outliers is basically you're looking for values that are far below or far above kind of the bulk of the rest of the data. And that is based on a computation called the interquartile range, or IQR. And the interquartile range is the last of our measures of spread. We've already talked about range, and we've talked about standard deviation. Interquartile range is another measure of spread. And because it is interquartile, it literally means between quartiles. So we would take, to find this value, Q3 minus Q1. And that gives us our interquartile range. In this case, for our set of data, our Q3 is 45, our Q1, 45, sorry. Our Q1 is 13. So when we subtract those two, we get an interquartile range of 32. And then here's how we look for outliers. we set up things that are called fences. These will not appear on the final diagram. They're just something that help us look for outliers. So with the fences, there's going to be a lower fence and an upper fence. The value for the lower fence is Q1, your first quartile boundary value, minus 1.5 times your IQR. And your upper fence is Q3 plus 1.5 times your IQR. Okay, so lower, 13 minus 1.5 times 32. Upper is 45 plus 1.5 times 32. And we'll just crunch both of those through. 13 minus 1.5 times 32 gives us a negative 35. And 45 plus 1.5 times 32 is, whoops, let's try that again. 32 is 93. Okay, so any values in your data set that are between the fences, that are between negative 35 and 93, those are just normal data values. Any values that are below the lower fence or above the upper fence are construed as outliers. Now clearly, since our lowest value is 8, we don't have any data that's below negative 35. But our highest value, 108, is above 93. So 108 is an outlier. Okay, so that's an important piece of information to note when we go to create our box and whisker plot. Now, here's how our box and whisker plot goes when we're ready to create it. They can be done either vertically or horizontally. I'm going to do all of mine horizontally because that's how the calculator does them, but your book will show both methods. So you need an axis, and it needs to be an axis that is long enough to accommodate all of your pieces of data, from the smallest to the largest. So let's see. I'm going to start at 0. You don't technically have to start at 0. You can start at whatever your lowest data point is, but I'm going to go ahead and start at 0 anyway. And these should be evenly spaced. You'll notice here, because I'm not doing this with an actual straight edge, they're not perfectly evenly spaced, but they should be. And I'm going in increments of 10 here. And you can go in whatever increments make sense for your particular set of data. Also, if we knew what these data were pertaining to, what the variable that was being measured was, we would want to put that amount down here. But, you know, put a label down here, but since we don't know, we're just going to leave it blank. And then normally what you would do, if there were no outliers present in the set of data, you would put a dot above the axis at both your minimum and maximum values. So normally there would be a dot at the 8, and there would normally also be a dot at the 108. But because the 108 is an outlier, what'll happen there is there'll be an asterisk here at the 108 to separate it out as an outlier, or some other kind of special character. It doesn't have to be an asterisk. It could be a star, a box, a little dot, but something separate from the rest of the data. And then, like I said, normally we would put a dot at the highest value if it wasn't an outlier. Here, since our highest value was an outlier, where the other dot goes, since we have a dot at the minimum, there also is a dot at the maximum value that's not an outlier. So our next lowest data value down, this one was the outlier, so we took care of that one already. So then we're going to put the next dot at 50. Okay, so there's a dot right here at 50. Okay, so that takes care of this piece, and it technically takes care of this piece also. Then you get vertical lines at Q1, the median, and Q3. So we're going to have a vertical line at 13, so right about here. We're going to have a vertical line at our median of 24, so right about here, and a vertical line at our Q3 of 45, right about here. And then the reason it's called a box and whisker is you draw a box around all the vertical lines and you make lines out each side, and those lines are called the whiskers. And just for added emphasis, you can label these. You know, this one was 13, this was 24, and this was 45, and here we have 50. You don't technically have to label those like that if you've included an axis underneath, but sometimes it's nice for emphasis. Now, had this value of 108 not been an outlier, this line would have extended all the way up to the 108. But because it was an outlier, it's considered separately, and then the line only goes as high as the next data point that's not an outlier. Okay. Now, what's really weird about this is at first it appears that box and whisker plots disobey the area principle, and actually they do, because what it looks like is there's more data between, say, here and here than there is between here and here. But what you have to remind yourself is that when you're looking at a box and whisker, each of these subdivisions contains the exact same amount of data. They each contain 25% of the data. So what this is in fact telling you is that this 25% of the data between 45 and 50, there's a lot of data really tightly compacted in there, whereas between the 24 and 45, there's the same amount of data, it's just more spread out. So that tells you that there's more variability in here than there is in here. Okay, so box and whisker plots are a little bit weird until you get used to looking at them. Now, that's how to make them by hand. Okay, so we just made that one by hand. You can also ask your calculator, especially once you've put in the data already. So we had our data in here. And let me zoom in on this a little bit so that you can hopefully see the calculator a little bit better. Let me focus that in just a bit more. Oh, that's pretty good. Once you've put your data in, you can actually ask your calculator to make your box and whisker plot for you instead of doing it by hand. And the way that you would do that is to press second y equals to go to your stat plot menu, just like if you were to make a histogram. Select plot 1, make sure it's turned on, and then down here where it says type, we want this one right here, this first one on the second line that looks like the little box and whisker with the 2 dots. The 2 dots will look for the outlier. If you pick this one, it won't look for any outliers. And the way to get there is to press the right arrow key until it drops down to that second line. And then press enter to select it. X list should be set to whatever list your data are stored in. Mine are stored in list 1, so that's fine. Frequency should just be set to the number 1 unless for some reason you had like a weighted average type of a list. But here we didn't have that. So I'm just going to make sure my frequency is set to 1. And then mark, here you can select the mark that the calculator will display for your outliers if you have any. And I'm just going to leave it at that first one, the box. Okay. And then you do zoom and option 9, the zoom stat. You can either scroll down to it or you can just press the number 9. And then there's our box and whisker plot. And you'll notice that I can see it pretty clearly, and it looks somewhat similar to what we drew here, but it doesn't have any values on it, right? There's no values along the axis. So if you want to see those, you can press the trace key right here, and at first it'll put a blinking cursor on that lowest value, and it'll tell us that's the 8. Then if you press the right arrow key up, it'll tell us that Q1 is 13, median is 24, Q3 is 45, this value is 50, and then our maximum, which was also an outlier, is 108. Okay, so exactly the same information that we got right here, we can get the exact same thing on the calculator.